students, welcome back to part 2 of lecture number 19, and here we are talking about the parameters for model evaluation, right. So, as you know, there are in the board I have written different kinds of parameters. Let me tell you on the slides also. So, these three things: data splitting, validation state, cross validation. You will always hear this K fold validation, cross validation when you develop certain model. So, I talked about it. Then we are going now to part number 4 and 5, the evaluation matrices. There are two types of problem we can handle. One is a classification. For that you need to know accuracy, precision, recall, F1 score, ROC curves or AUC. We will see that area under the curves. There are other matrices like regression problems. You have MAE, MEC, RMSE, R square. Then you have baseline comparisons, addressing biases and fairness. I talked about it, and monitoring the post deployment. So, first let us talk about these aspects. What is the classification problem? In confusion matrix is what is widely used as a model evaluation parameter in classification problems. It is basically nothing but a table made up to measure how well a classification model performs. How do you do that? By comparing the predictions made by the model with the actual results, and also show whether the model was right or wrong. That means you must have knowledge of actual results. You can compare your model prediction with the actual results. So, what does it do? It helps us to understand how the model is making mistakes, and that so that we can improve. So, what the table looks like? Table looks like this: actual positive, actual negative, predicted positive, predicted negative, right? You can see that. So, positive means what? That is correct. Negative means wrong. You have to understand. Actual positive means the actual aspects results are correct. Actual negative means actual aspects are wrong. Predicted positive means the model predictions are correct. Predicted negative means model predictions are wrong. So, depending on that we can create 4 different parameters. So, I will tell you that true positive, the model correctly predicted a positive outcome and the actual outcome was also positive, right. So, that means what? Model is going to predict, right, something. So, you see the prediction is correct and outcome is also correct. Outcome means actual outcome, which is coming from experiment or something, right. Models have predicted a negative outcome and actual outcome is also negative. Okay. False positive means model has incorrectly predicted a positive outcome, but actual outcome was negative. This is also known as a type 1 error. Although you may not remember after some time, but false positive is what you should remember. False positive means model incorrectly predicted a positive outcome and actual outcome was negative. False negative is what? Model incorrectly predicted a negative outcome and actual outcome also was positive, right, that, correct. In case of false positive, actual outcome was negative and model has predicted a positive outcome. That is why it is called a false positive. Model is predicting a positive, actual outcome is negative. But in case of false negative, model is predicting negative outcome incorrectly and actual outcome is positive. This is also called as a type 2. This is also taken for Geeks problem. So, what are the different parameters you can matrix you can use? I told you, right, accuracy, precision, recall, F1 score and specificity. There is many more actually. So, what is accuracy? Accuracy is also used as a statistical measure how well a binary classification test is correctly identifies or exclude a conditions. So, accuracy is like TP plus, TP means 2 positive divided by 2 negative plus 2 negative divided by the whole thing, 2 positive, 2 negative, false positive, false negative, right. Correct. You see that here you have everything 2 positive, false negative, false positive, false negative, right. You can build your confusion matrix like that way. That is what is confusion matrix means, and then you can form. Therefore, you have to first make your confusion matrix, right, and this is very important when classifications things are done. Decision tree is one classification algorithms, like there are many other classifications like SVM is a classification algorithm. So, classification algorithms you have all the either wrongly predicted or correctly predicted. Based on that you can make this table and do that. So, what is accuracy then? Accuracy is TP plus Tn divided by total 1. Okay. This is basically proportion of, it tells you proportion of the correct predictions among the total number of predictions. Both are true positive and true negative, so basically correct prediction, right. So, now what is called precision? The positive and negative predicted values, sometimes we call positive predicted value as a PPV, negative predicted value as a NPV, are proportions of positive and negative results in statistics, correct. And these PPVs, NEVs can be used as a diagnostic test for a measure. So, precision is sometimes as a PPV, that is nothing but a number of positive, 2 positive cases, thereby 2 positive plus 2 negative. So, if I have to write in terms of this one, this is called 2 positive divided by 2 positive plus false positive, correct. That is what it is. You can clearly see that. So, 2 positive will tell you number of 2 positive cases, and this summation will tell you number of all positive calls, correct. That is how we can actually calculate the precision. Precision is very important, how precisely the model is predicting the things. Otherwise, you can calculate also PPVs, NPVs. I am not going to tell you what is how the NPV is collected. NPV will be similar. Instead of 2 positive, you have to use a false positive there. Okay, that is what NPV is. Okay, so false positive divided by 2 positive plus false positive is what is called NPVs. So, recall is something very simple. Recall is measures how good a model is at predicting the positive values, right, how good it is. That is what is the aspects about your recall. So, recall measure how good the model is predicting the positive. It shows the proportion of the 2 positives detected out of the all actual positives outcomes, right. So, recall is always written like that, Tp by Tp plus Fn. Recall is given by that, this Tp by Tp plus Fn. So, Tp is 2 positive divided by 2 positive plus false negative, right. So, as you told that it shows the proportion of 2 positive detected out of the all actual positive outcomes. F1 score is nothing but basically a means, harmonic mean of both precision and recall. That is why it is written 2 divided by recall inverse plus precision inverse. So, if you do that mathematics properly, it becomes 2 multiplied by precision into recall divided by precision plus recall. Its statistical analysis, F1 score or F score is a measure of test accuracy, very important parameter. It is calculated from both precision and recall. Precision is the number of positive results divided by the number of total positive results, and therefore, it provides you much better. Recall is number of positive results divided by total number of all sample that should have been identified as a positive. So, that is why this F1 provides you much better things. It basically combines precision and recall, and it provides you informations about test accuracy, very important parameter. So, now let us talk about a little bit about specificity. Specificity is basically another important matrix which is new to you probably, and it for specificity, F1 score, recall, precision and accuracy, or rather accuracy, precision, recall, F1 score and specificity in a nutshell provides you almost all the evaluation parameters, almost all the replacement for the classification problems. You understand that. So, now you can have other things also. Let me tell you, these are called AUC and RUC. What are these AUC, RUC? Let me explain to you in the board, that will be better. Then we come back to your specific aspects about your regression analysis. So, as you know, AUC and RUC, they are basically a graph. They are basically a graph which are used widely to obviously find out how the model is performing well or bad. AUC is area under the curve, as you understand. It is called AUC RUC. They check, normally this is used to check binary classification like yes or no type of thing, or 0 1. Okay. And it helps us to understand how well the model separates the positive cases from the negative ones. That is the main idea. So, you already have seen the matrix for true positive, 2 negatives, right, 2 positive, 2 negative, false positive, false negative, right, these matrices, this you have seen. So, how can I use that as a, so this is coming from the again from that matrix, correct. So, AUC basically stand for area under the curve, that is what is called AUC. It allows to understand how classification model distinguishes different classes, correct. So, if I draw that, let us say it is true positive, red and false positive, red. Red means how it is happening, and you have a curve like this, correct. You can just draw a line, and this is what is area under the curve, right. That is what is provides you that, okay. And this portion is called ROC, remnant of the curve, okay. So, basically it used for binary classification, and it allows you to find how the classification model distinguishes these two classes, okay, true positive and false positive, okay, these two classes, how well it can do. This is the main aspects of the AUC ROC. It is normally used only for binary classification, so you do not worry much about it. So, now what about other matrices, okay. Let me go back and the board and discuss about it. These are used for your regression analysis, other matrices, and there are lot of equations involved. So, I just wanted to explain that, so how it can be used or not, okay. Let us one by one discuss. So, this regression analysis or even many other analysis requires you to use these parameters as an error or analysis. The several ones, so we will discuss few of them, we cannot discuss all of them, and you may not require all of them. Remember, these are used for regression type or that kind of modeling, okay. The earlier one was for classification. So, first thing is what is known as a mean absolute error. From the name itself we can understand, okay. Nobody calls it like that way, people call it MAE. What is that? This is nothing but absolute difference between the predicted value and the original value. So, what is it? MAE is written by this formula 1 by n, n is the number of instances, summation of this error j going to 1 to n yj minus y hat j. So, y hat j is basically the actual value, that is a predicted value. So, difference between these two is going to provide you the error, absolute error. So, if you then you want to add it up for all the n instances, divide by the number of instances, that is what gives you the mean absolute error, okay. Remember that it is giving you absolute value of the error, correct. That is very important many cases, but sometimes it is misleading. So, it gives you clear view of the model prediction accuracy, but it does not throws whether the errors are due to overfitting, under predictions or many other problems or interpretation problems or not. It only provides you the model whether predictions are correct or not. That is why you have to use. So, let me tell you this y j and y hat j, there are two things I wrote, right. So, what is y j or y hat j? Y j is the actual value. So, I think I told you wrongly in the last time. So, y j is actual value, y hat j is basically predicted value by the model. So, difference between these two is what is used. Then come the mean square error. Mean squared error. Error has 3 R's, you have to understand that, and this is called MAC. What is that? Basically, it will take square of that simply. So, it is also 1 by n. We take the square of this j going to 1 to n yj minus yj hat whole square. Okay? Can you see that? So, basically squaring the difference ensure larger errors are penalized more heavily. Larger errors that penalize more heavily helps in making us sensitive to outliers. The larger, because you are squaring that, so larger errors which are due to large difference of predicted and actual values are penalized more, and that because they are sensitive to outliers. Okay. So, therefore, it is useful for if the errors are undesirable, but cannot be problematic when outliers are present. It is more related to problem of outliers. Let me tell you, if there is a lot of outliers in your data sets, the MAC error will be very high. Third aspect is what is known as a root mean square. Root mean squared error, that is called RMSE. Okay. What is that? Basically, you take a root of that. So, RMSE is a root of this, same thing whatever I have written, j 1 to n yj minus yj hat whole square divided by n, that root, that is what is called RMSE. Okay. So, it brings the metric back to the original scale. Once you square, it becomes square of that. So, if you want to keep it, bring it back to the original scale, MAE scale, you have to take a square root of that, and it tells you heavily penalize the larger errors, but easier to interpret at is the same unit as the target variables. It is always useful if you want to know our prediction deviate more from the actual values. That is why it is widely used. Okay. So, then you have a something known as a logarithmic error, root mean squared logarithmic error. This is not so widely used. So, you can actually, instead of doing that, you can actually take error. So, let me write down that. So, that is called RMSLE, that is equal to summation j 1 to n. First you take a log yj plus 1 plus 1 minus log yj hat plus 1 square of that divided by n. Okay. I hope you can see that. Okay. So, that is called root mean square logarithmic error, and this it can span a wide range of values. Unlike RMSEs, it it can take up underestimations more than overestimations. That is why it gives you much better output that. The last thing which I will talk about it, let me keep it this and write it here, since you have space what is known as R square, that is called number 5 R square, and this represents proportion of the variance in the dependent variable, proportion of variant. Okay. Therefore, here you calculate variance in the dependent variable, that is y. So, how do you calculate it? This is nothing but 1 minus 2 terms j 1 to n yi y hat j square divided by summation j 1 to n yj minus y bar whole square. So, everything is same, the y bar here. So, yj and yj hat is same, y bar is the mean of the actual values. Remember, actual values, not predicted. So, here in the top you are using the actual value minus predicted value, correct? You can see that, and the below you are using, basically this is the variance, correct? The difference between the actual value and your mean, that is what is the variance. This will be a fraction and you have to subtract from 1, that will give you the R square value. We always feed data and find out R square, right? 95% R square, 92%, 96%, 80%, you must be doing that. So, these are the parameters we always use. Other than that, there are many other parameters which can be used for different purposes, like you can use for your clustering problem, which I am not discussing. I can simply mention that in the here. One is known as a seal. This is used for clustering. Okay, clustering. This is called seal Haute score, and this is nothing but a b minus a divided by maximum of a b. Okay, where a is the average distance between the sample and the all points in the clusters, and b is the average distance between the sample and all points in the nearest clusters. You remember the clustering, right? There is one cluster, there is another cluster. So, b corresponds to nearest distance between the clusters. Okay, a corresponds to this one. Okay, that is what is talked about it. You can also use another one parameter called Davis Baldwin index. This is basically talks about average similarity between two clusters. Okay, and this is written like this: 1 by n j going to 1 to n maximum maximum I not equal to j. This is a very complex formula, but sometimes they give you better result. I not equal to j ai plus aj divided by d ci cj. Let me explain what is this. Sorry, not ai, sigma I sigma j. Okay. So, let us write it properly, otherwise make it confusion. So, what is sigma I sigma j and what is a d? Let me explain to you. So, here what you do is very simple. Sigma is the average distance between the point in the clusters, sigma I average distance, remember that, and d. So, these are all two clusters I and j, where I and j are not equal to each other. D ci cj is nothing but distance between the centroids. Remember the centroids, right? K means clustering, distance between centroids of cluster I and j. Sigma is the average distance and this sigma j is also average distance in the clusters. There are two clusters in case of sigma I for one cluster, sigma j is for the next clusters, and d is the distance with the center of the clusters. So, this is my centroid, let us say this is my centroid. So, these two are the this is a d c I c j, okay, cluster I, cluster j. So, these two parameters are used for judgment of the clustering. So, let us stop here, and so in the next lecture, that is the last lecture, I will discuss some important aspects. What is that I am going to discuss? Let me tell you also, go back to the first slide. Yeah. So, we are going to discuss about mapping of materials, some aspects, and I will talk about some SkyKit problems, that is different kinds of Python scripts. Thank you.